In UniFi network controller, if you go to clients, you can see a colorful device list with beautiful icons. So this feature is implemented using a thing called device identification. From the face, it's a very exciting, very promising feature, but as long as you use it for a while, you will realize it's a very buggy, very frustrating implementation. For example, this is just a random subset of my devices. Just after a brief glance, I already noticed multiple issues. For example, the first one, yes, the client name is correct, but the icon is wrong and the vendor is wrong. In this one, the host name says it's Apple TV, but the icon is an iPad. Apparently, it's screwed up. So in this video, let's talk about device identification for UniFi gateway. By the way, on the web, the most complained issues about UniFi device identification is about the device icons. In this video, I'm not going to talk about that, and I don't have high hope for Ubiquiti to resolve that, but that's not the point for this video. In this video, we are going to discuss how device identification is implemented except for the icons. In the first part of the video, let's clarify a confusion. You may know device identification is related to DPI, but what's the exact relationship? Let's explore it. So in UniFi network controller, if I go to settings, security, you can see these two options, device identification and traffic identification. By default, they are both enabled. This particular UniFi help document really made the situation even more confusing because it talks about the traffic and the device identification together with DPI. So if you read this very short document, it may give you the impression that traffic and device identifications together equals to DPI, but it's not really the case. In fact, the confusion is partially due to Ubiquiti's bad practice by introducing new fancy terms to replace some common industry terms. For example, all other vendors, they use DPI, but in the new UniFi gateway, you don't see DPI anywhere. You only see traffic identification, but the DPI setting is still in the old legacy UI. So let's do some simple testing. In the new UI, let me disable device identification. Then let me go to the legacy UI. In the legacy UI for settings, DPI, you can see DPI is still here. It is enabled. Remember, I just disabled device identification, right? In fact, what's really disabled in the old UI is the enable device fingerprinting. Just by disabling device identification won't disable DPI. But let me disable the DPI here, apply changes. Then let me go back to the new UI. You can see not only device identification is disabled, but also traffic identification. In fact, the traffic identification setting equals to the old DPI setting. If I just want to enable device identification only, you can see it doesn't allow me to only enable this one. I also need to enable traffic identification. If I accept it, you can see both are enabled, right? Apply changes. Then let me go back to the old setting. You can see DPI is also enabled. After this back and forth simple testing, I just want to show you if you want to have the device identification, you have to enable DPI. But if you disable device identification, the DPI is still enabled. In the legacy UI, the relationship between DPI and device fingerprinting is very clear, but because of the fancy new terminologies and the new UI design in the new UI, it's very confusing. Here on the screen, you can see two UniFi network controllers. The left one is for UXG Pro, the right one UDM Pro. For the left one, for UXG Pro, I enabled DPI but disabled device identification. But for the right one, the UDM Pro, I enabled device identification. So then let's SSH into the gateway to see how the backend is configured differently, just because we have different device identification settings. Let me SSH into the system. Okay, I'm in. In the left side, let me try to find any process with the name DPI in it. Okay, there is one. It's called DPI flow stats. You can see it's using this configuration file. In the right side, the same command, the exact same result. So then let me display the configuration file in the two SSH sessions. It's very simple. The only line related to this video is this one. It's called fprint, meaning fingerprinting. More specifically, device fingerprinting. Because we are talking about device identification, the device fingerprinting is 0, means we do not want to do device identification. Then in the right side, let me display the same configuration file. It's a little bit different. Just because it will do device identification, it enabled a Wi-Fi service with this part, and the device fingerprinting equals to 1. Now I know a progress called DPI-flow-stats, right? Process name is pretty long. Let me use netstat command to see what this process is doing. I'm using the shortened process name. Okay, so the first 3 lines tell us this process is listening on these 3 parts. We already see from the configuration file, this one is for Wi-Fi, right? And I believe this one is for device discovery. I'm not sure what's this part for, but the real interesting thing is these 2 lines. These 2 lines means it's using protocol Unix. Unix meaning it's Unix socket. In Linux operating system, 2 processes can communicate using file. In this type of communication, the protocol is Unix. It's not UDP, not TCP. Then the other side, the name is called Ubiquiti DPI sock. So the @ sign here in Linux is called abstract namespace. Basically, that means Ubiquiti wants to bind a Unix domain socket to a name without that name being created in the file system. To find more information about the DPI flow stats process, let me run lsof to see the open file from this process. Okay, you can see this process has multiple files opened. For example, the file descriptor 20 and 24, they are both about the Ubiquiti DPI sockets, the Unix domain sockets. But I don't see the other end of this socket. I'm not sure this socket is between the network controller and the DPI flow stats, or between the hardware DPI functionality and DPI flow stats. I don't have the answer. Just to find out more details about the DPI flow stats process, I already launched 2 separate terminals. In the left one, let me kill the process for the DPI flow stats. I can find the PID here. Kill it. Oh, wrong ID. Okay, it's killed. Then let me see whether the process is still there. Okay, the process is still there, but it has a different PID, which means something relaunched the process after we kill it. I suppose it's a watchdog to see what happened after I kill this process. So in the right side, let me show the last 50 lines of the syslog. See, starting from this line, the DPI service is disconnected, then it start to connect to it again. It got the process exit event because we killed it. Then see this line, a watchdog is restarting the process DPI again. So that's why we see another run of the DPI flow stats, right? Here we can see some interesting statistics. It loaded 6 clients. And in the UniFi network controller, we can see now it's showing 3 active clients. I assume the other clients are the UniFi devices, for example, switches. So they are not listed as clients. then you can see, okay, it's reading from UIDB. I guess it's reading some historical data. Then you can see another interesting information, DPI client limit 5,000. If you read the UniFi's technical specification for UDM Pro carefully, you may see it can manage up to 1,000 clients. But here, interestingly, for DPI client limit is set to 5,000. And then here you can see the DPI flow stats is started. UD API server is connected to DPI client. So just from syslog, we already found a lot of interesting information. Based on what I observed from these two separate sessions, I draw this diagram. So here you have the UniFi network controller. It runs watchdog and it read the statistics from DPI flow stats. That's why on the UniFi network controller, you can see different beautiful charts about the network statistics. Now let's see it works in action to observe several strange client identification results. So I'm going to use two different UniFi gateways. Each one is connected with 4 almost identical devices, a surveillance camera, the same model, Linux bridge from the same server, and 2 Proxmox virtual machines cloned from the same freshly installed Debian Linux. So let's see, just because we do or do not enable device identifications, how the two UniFi gateway will react differently. Okay, so these are the two network controllers. Now they are both showing 4 devices, but with dramatically different results. Remember, I already mentioned I connected 4 almost identical devices to the two UniFi gateways, right? Let's compare them. The first one is UXG Pro. I disabled the client identification. That's why it makes sense. It doesn't have any custom icons, and the name simply reflects the host name. If the device doesn't have host name, it will show the MAC address. And then, of course, MAC address directly comes from the device. Then about vendor, we will discuss how the vendor information is retrieved even though we don't have the client identification enabled. And then you can see the connection information, the network, the IP address, right? Everything makes sense for the first UniFi gateway because we disabled client identification. Then move on to the second UniFi gateway. It's a UDM Pro. I enabled the client identification. So the first one is for the Linux bridge because it's from a Dell recommend server. So the vendor is Dell, MAC address, no problem. And the name, it doesn't get the name because it's a Linux bridge. It doesn't have a host name. And you can see I even didn't assign IP address to it. So the first line makes sense. Even though we have the client identification enabled, I really don't think any magic can happen so that the system will even know it is a Linux bridge. So I'm totally fine with the first one. Then about the second one, see the strange information. As I mentioned, it's a Proxmox virtual machine running on a Dell recommend server. It has nothing to do with Raspberry Pi, but the vendor is showing as Raspberry Pi Foundation. Host name, later I will talk about it. It's wrong as well. It's not the correct host name. And then it's showing the Raspberry Pi icon. It's wrong, right? Move on to the third one. It has the wrong host name. We will find it out later. See the vendor? It shows Red Hat. These two virtual machines, they are almost identical Linux virtual machine running on Proxmox. I don't know why the first one show as Raspberry Pi, the second one show as Red Hat. None of them is showing as Debian or Proxmox. And then the fourth one is even funnier. Remember, this is a surveillance camera, right? It's a third-party one, not Ubiquiti Protect. It's from Hikvision. So I expect to see vendor as Hikvision, but the vendor is showing Sony and the device name is shown as Sony BDP. It's not a Blu-ray player. It's just a surveillance camera, right? So we will dig deeper to see how the system even came with these horrible results. 3 out of 4 are completely wrong. Let's get the easiest thing out of the way first. For the first UniFi gateway, we don't have the device identification enabled. How the system even know the correct vendor for the 2 devices? So let me take an example. Proxmox virtual machine. In the lower part of the screen, let me use the free OUI lookup tool. This one is from Wireshark. OUI stands for Organizationally Unique Identifier. Basically, it's the first 3 numbers when you check the complete MAC address. In this OUI search box, let me put the number. Okay, find Proxmox server solution. That's exactly where this vendor information coming from. Then let's move on to the troublesome second gateway to find out how the system get this ridiculous information. Let me find where the DPI flow stats command is located. So use find command starting from root folder to find this command. Okay, it's under user SBIN. So let me cd to the folder. Let me see what other commands has DPI in it. Okay, I see this interesting command. It's called DPI utility. The name implies it may help us to troubleshoot. So let me try to run it directly. It's even more helpful. See, it tells you what parameter to use to find more information. So these parameters, just by the name, we can already guess what they are for. For example, the fprint stats is for fingerprinting statistics, more specifically for our device identifications, device fingerprinting information, right? Let me run DPI utility with fprint stats parameter. So it seems to be a pretty long list. Let me try to find these 2 virtual machine information because they should have been very similar, but from the UniFi controller, it gives me totally different wrong information, right? Let me find these 2 devices fingerprints. For the IP address .1.51, yes, it's here. And just for comparison perspective, in the right side, let me run the same command. Find the other device, the IP address .1.190. Okay, it's here. If we compare these 2 sections for the 2 different devices, amazingly, except for IP address and MAC address, all the other fields, they are exactly the same. On one hand, from UniFi Network Controller in the device list, we see for these 2 devices, they have totally different identifications, right? But on the other hand, from the backend, from the fingerprints information, they have the exact same identification except for IP address and MAC address. Why is that? Either Ubiquiti has an unbelievable bug here, it messes up the information, or more possibly, Ubiquiti uses other information to tweak the identification information. So the only information I can think of is the network traffic, the same information out of regular DPI, Deep Packet Inspection. Let's look deeper into the DPI information. If I run DPI utility command using another parameter, DPI stats, I will receive a lot of DPI aggregated statistics. Let me try to find the information for this particular client. It has IP address .1.190. Luckily, the very first one is for this IP address. So let's see what's inside the DPI statistics. There are multiple sections. Each section is for each app. For example, from your device, you may, let's say, watch YouTube, listen to music, write email, or transfer file, right? Each different type of activity may come from a different app. For each app, Ubiquiti has a ID. The app belongs to a category, and the category has its own ID as well. From the traffic, Ubiquiti can tell the country of the other side. Then it can aggregate the traffic information, the receive transfer bytes, right? So let's try to find out what are these magic numbers. For example, app 194, category 20. What they mean exactly. So in the right side terminal, let me go to this folder, user share DPI. So in this folder, you can see 4 subfolders. To understand the DPI application ID and the category ID, let's go to TDTS folder. You can see the rules file and the DB file. The DB file, in fact, is simply a pure text file. So let me VI it. You can see the first 3 columns, they are for IDs. First column is the category ID. Second column, the application ID. And it seems the third column, they are always 0. Of course, the very last column is the app name itself. It's a super long list. So in the left side, we see the first section. The first app is app 194 in category 20, right? Let me search the file in this way, try to find 20,194. Okay, I only see one line. It's let's encrypt. The virtual machine communicated with let's encrypt. Move on to next example, application file, category 3. Okay, in similar way, only the first line is what we want. You can see it's web file transfer. So move on to the third app for the same device, category 20, app 185. It's SSL TLS. The next one, 20186. It's Google APIs. Move on, 20199. DOH. And the very last app is this strange category and the strange app ID. Just from the number, you may already guess they are for special case. They mean others or invalid. But let's confirm that. Okay, in the database, it simply doesn't have this category, this app. For this section, it simply means Ubiquiti doesn't have a category and app ready for it. So it simply categorizes whatever packets they don't understand to this section. Interestingly, you can even see for country code, it's ZZ, means other. We did all the investigation, we found all the category IDs and application IDs. What's next, right? Remember, we are talking about this particular device, right? If you go to the insights, you can see all the application and the traffic. If you go to view all traffic for the past hour, for example, you can see all the categories. See whether it's familiar, SSL, TLS, DOH. We see them in our backend investigation, right? The front end skipped several, so it only included 2 most important category for this example. But in backend, we can find more, right? That explains where the UniFi network controller even get the statistics, the insights, the network traffic information from. It's from DPI. We can see more detailed information by looking into the DPI utility. But the reason we are even doing this is not to understand the UniFi network controller insights. We are trying to understand why Ubiquiti categorized this particular device as a red hat, right? Because Ubiquiti's DPI engine is its own proprietary implementation. There's no any documentation. But based on what I have observed, this is my theory. To complete the device identification process, of course, it needs the raw original information about IP addresses, MAC addresses, host names, right? This information can be easily obtained. Then by using DPI, the gateway can get the statistics for device fingerprint and about the network traffic details, the app ID and the category ID, right? Then to consolidate all the information, Ubiquiti applies its own rules. I did look into the system and found multiple rule files, but the crucial ones are in binary format. Again, it's proprietary, so Ubiquiti doesn't want you to change or even understand the rules. But there are rules in the system. Gateway will apply the rules and to come up with the final device information, which we can see from the UniFi network controller, the client information. But in many cases, it seems Ubiquiti is too aggressive, it's too optimistic about the confidence score, so that it will screw up a lot of device identification information. For my case, I prefer to disable the device identification because, as shown in the slide, at least for the original for field, I can clearly know what the device is. But if I look into this misleading wrong device fingerprint information, I will only make wrong decision. Okay, this is the end of the video. Thanks for watching.